Hey again. All right, so to make your lives a little easier, for situations where you're starting and ending at the same height, there's a particular equation that we like to call the range equation that helps you calculate how far out something travels given an initial velocity and an angle, also assuming that you're on Earth with gravity and all that. So this is going to be something for your equation charts. I just want to point out what would be going into your equation chart. So this is for finding the displacement in the x direction, also known as range. And then that equals the initial velocity squared over g, 9.8, times sine 2 theta. Now, the conditions for this, they're really, really strict conditions. People sometimes misapply this. They just see the word range and they're like, oh, range equation. Range really just means x displacement, but the range equation is only for situations where the dy is 0. Gosh, what does that mean? That means that you're starting and ending at the same height. So if you're dropping things down a cliff, or you're throwing something up to the top of a cliff or a ladder or something, this is not the equation to use. This is for when, let's say you're throwing snowballs from ground level and they're going to land at ground level. Or you've got a cannon or something and you're starting and ending at the same height. That is when this is going to be useful. And to be fair, this is going to be useful for your launchers. You may not exactly be starting at ground level, but I think we may be able to assume that it's pretty close to ground level. Some of them, that may be a better assumption than others, but we can deal with that on a case-by-case basis if we need to. So again, here's the equation. It's only for when the beginning and ending height is 0, or I'm sorry, where the beginning and ending height is the same. And g in this case is positive 9.8 meters a second squared. This is one of those cases where it's going to be strictly positive, absolute value. And then in this case, the initial velocity is not the velocity in the horizontal direction or the vertical direction. It's just the velocity that's at some angle. So in the other part of this theta is the angle that it's launched at. So in the last problem we had a projectile going at, I believe it was 60 degrees at 10 meters a second. And so you could theoretically find how far out it landed using this equation, where this is the initial velocity and this is the angle. Again, make sure you're in degree mode for sure. Also, theoretically speaking, what is the maximum that sine of some angle can be? The most it can be is 1. And so in this case, what I've drawn here as x is 2 theta. So what angle will give you the farthest range that will maximize this to be 1? Well, if it's sine 90, sine of 90 degrees ends up being 1. But that's not our theta. So it works out that if 90 is 2 theta, then theta equals 45 degrees. So that's going to be our maximum range launch angle, at least theoretically speaking. So at this point, I think you may be ready to do a little sheet on something we call the exploding whale. I apologize, it's kind of gross. But just keep in mind that it's already dead. Right, so listen for the amount of distance that they tell you in the video, and then you should have timers to Uh, Actually, maybe you don't have timers. That's okay. That's fine. Um, Figure out the initial velocity, knowing the range, and knowing that the uh, best angle is 45 degrees. See if you can find the initial velocity. Okay, good luck.